Hello, my name is Colin Doyle. I'm a senior consulting engineer at Juniper Networks. Welcome to the 9th video in my updated Apstra and EVE-NG lab series. Today's going to be a fun one. We're going to be working on core/WAN connectivity. Our current state is a working fabric. In fact, it's the end state from video 7 and from video 8. In video 8, we walked through doing direct peering between two fabrics with no transit routers in the middle. And then at the end of that, we actually restored it back to the state it had been in. That state is as follows. We have two working fabrics, DCA, DCB, and we have OTT DCI between our border leaves. Today, we are going to modify the connectivity between these border leaves and these upstream routers. We're going to peel the DCI out of the untagged interface that it's in and add a tag so that we can continue to use these same interfaces and layer on another subnet for transit that is sourcing from our tenant. And in doing so, we are going to connect our tenant directly to a routing instance on these routers. And from there, we would be able to give them connectivity to anything those routers happen to connect to. The end goal here is that connectivity, and the way that we're going to demonstrate that it's working is by creating a default route on these external routers that has just a next hop that's a discard and advertising that into the fabric. If we see that default route propagate down to the border leaves, then we'll know that it's working as intended. And it might seem like somewhat of a wishy-washy proof because I don't have these other hosts that I can connect to. In the next video, we're going to leverage that same connectivity and build connectivity out to the public internet through my lab firewall that is actually external to the EVE-NG server that I'm running. So the reason I'm not including it here is because if you do want to see the proof that it is working the way it's supposed to, that's kind of covered in the next video as well. There is another thing that's worth calling out as a part of this, and that is that there's two different ways that I can modify the existing connectivity templates that I have that defines the connectivity between these border leaves and the external routers they're connected to. I'm going to show you both methods, as I've done in a previous video when there's a difference. I think it was in the template video, which would have been way early on. I'm going to show you one of the methods in DCA, and I'll show you the other method in DCB. I think there's use cases, arguments to be made for doing both, or either, I should say. And I just want to make sure that you have the information you need to make the right choice for whatever you're trying to do with your lab. The other thing is that I want you to stay focused on more of the intent of what I'm trying to show you. These next few videos, this one and the next one, are going to start dealing more with the external devices that sit outside of Apstra. Since Apstra doesn't manage or control them, you're going to be seeing how I'm doing it, how I'm configuring protocols on these external routers, the choices that I'm making for policy. Just focus on the intent of what I'm trying to do and then adapt that intent for whatever environment you might happen to have. Don't get lost down the rabbit hole of the specific set commands I use on my external routers. Try to blur your eyes and see through the magic eye painting to the boat of what we're trying to accomplish. And in this case, what we're trying to accomplish is first preserving the existing DCI so that we can reuse the links that we have that go to our core router. We need to do that. It has to be its own broadcast domain. So we're going to be modifying what we have already and making sure it's still working so the DCI is fine. And then we're going to be layering on additional configuration to connect that tenant routing instance, that VRF, that virtual network, to a routing instance that's on that DCI router. And from there, hopefully conceptually, you can understand how we could then use that routing instance that's on that external router to connect into other core resources that obviously aren't represented in this lab that I have, but would exist in a production environment, or maybe even the lab that you're making if you wanted to add some other stuff. That's enough jibber jabber. Let's get moving. The first thing we need to do, as I suggested, is segment the DCI that we currently have. This peering here for DCI is going over untagged interfaces. unless we wanted to add additional physical interfaces for our out-of-band. And there might be a reason that you do that. I almost said out-of-band there, but for the tenant connectivity to the core, I don't think most folks are going to do that. I think that you're going to have probably high capacity link aggregation that goes between these devices, and you're going to use that LACP capacity and then layer on within there different sub-interfaces that are going to connect your tenants to your core. So we're going to do it that way. There are two methods. In the documentation, you'll see that I keep these separate. There's a discrete method. The discrete method means that we have more connectivity templates. If I go to the connectivity templates here, I've already got this external router connectivity template. Since I'm going to be doing VLANs and not just untagged interfaces, I'm going to have one connectivity template per border router because I'm going to have unique VLAN IDs on those border routers. In addition to that, for DCA, I'm going to create two new connectivity templates, one for each border router that is going to be specific to the WAN core connectivity. In DCB, we're going to take the two, not one, obviously we're going to have two, DCI connectivity templates, and we're going to add within those templates additional configuration that will allow us to accomplish exactly the same outcome. And you'll see the similarities. At the end, the only difference is that DCA is going to have a total of 6 connectivity templates. There will be 2 of these, one for each border, and then there'll be 2 more, one for each border, that are for the WAN connectivity. And DCB, there's only going to be 4. There's going to be 1 for each border, but within there are going to be both the DCI and the WAN core connectivity configuration. Hope that made sense. If not, kind of just, you'll see it'll make sense as we follow along. So the first thing you need to do is actually edit this one. There's no reason to delete it. We're just going to update it. And at the end of it, we're going to add border 1. Great. And I'm going to move to here. And if I click on my IP link, I change this to tagged, and I'm going to change this VLAN ID to 3, and I'm going to update, and that's it. That's all done. I wish I could copy this, but I can't. I'm going to say add template, and this is going to be ext-router-ct_border2. We're going to build this out exactly like we've built out all the other ones we've ever built out so far. We'll say we have an IP link. It's going to be a routing zone that is the default routing zone, because this is the DCI. We're only working on the DCI right now. We'll do the tenant routing zone when we do the core WAN connectivity. This is tagged. We're going to give it a VLAN ID of 4. We're going to do the exact same peering type configuration that we've done in the past, and we're going to use exactly the same policy that we use for DCI OTT. We'll save that. We'll notice that we misspelled this, and we'll go back in and fix that. And then we need to reconfigure the connections. This is still, since I edited it and I didn't modify the ports it's connected to, it's still assigned to both borders. I'm going to undo that. This one is border 1, so we want to make sure that it is only associated to border 1, and then we'll associate the other one to border 2. There we are. Sign. I'm going to commit this blueprint. It's going to break the DCI. The reason it's going to break the DCI is because our external router is still expecting untagged traffic. So our next step after this commit is going to be to add configuration to our external router. Like always, when we're doing this type of reconfiguration, this is included in the documentation that will be part of the thread that is associated with this video on the Juniper Elevate community. I will type it in. You can follow along here. I would also recommend you download that documentation. Configure. We're going to start by renaming interface GE001 unit 0 to unit 3. Set interfaces GE001 VLAN tagging. That enables tagging on the interface. Unit 3 VLAN ID 3. We're adding the VLAN ID to that. And then we're going to do the same for the other interface that is connected to that border leaf 2. GE002, unit 0 to unit 4, and then set interfaces GE002 VLAN tagging, unit 4 VLAN ID 4. Great. Show interfaces. You'll see that we are not changing our IPs. That's information hasn't changed. The DCI IP configuration remains the same on Apstra, and it remains the same on this router. Usually, if you do any of this out of sequence, or if you just run into a rando problem, go double check your protocol sessions in Apstra. I'm going to commit this, and I'll show you what I mean. This information shouldn't change, but if it does, you go here, you go to protocol sessions, and you double check this, right? So if you follow the same procedure that I'm doing, this won't get out of sequence. I did this in a different work stream, and I ended up having different IP addresses on either side. And in fact, I think I note that in my documentation. So check but verify, trust but verify, pardon me. It might save you a headache. Let's see, obviously we have BGP anomalies show, BGP summary off the router, and I see that we're established, so we know it's working. We don't really need to wait for those to clear, because we know if we click on this, it's going to be the external connections. Oh, one of them's already cleared, so that's great. Oh wait, I would say 2. It's spine 2, generic gateway. That's interesting, because this is actually... Oh, there they are. It was just hadn't updated yet. All right, so that's the 2. What you were seeing just there was actually from the last video, which I just recorded minutes before I started this one. Probably just more refresh lag. Unique to my environment. Folks, bear with me. It's just a function of the combination of using a virtual lab and the way that my Zscaler is configured. Moving along, let's go do the same for DCB. And at this point in the workflow, since we're just updating the DCI stuff, nothing is different. These work streams are the same for DCA and DCB until we start doing the tenant connectivity. So we'll do exactly the same thing we did DCA here. We'll rename this. We'll go into the IP link. You'll note I just clicked it. Usually I click over here, but I didn't this time. And we're going to change this to 13. Essentially the same values as DCA, except I'm going to add the number 1 to the beginning. And I'll update that, and I'll create a new one that says DC was for border 2 instead of border 1. Add a template. ext router ct underscore border 2. Primitives are IP link, BGP peering generic system, routing policy. Edit this, routing zones default. Again, it's the underlay, tagged 14. Scroll down, interface peering for BGP, and for our routing policy, ext create. Update our assignments, make sure that border 1 is only on border leaf 1, then assign border 2 to border leaf 2. There we are. We'll commit this. Scroll in my instructions, and now we will edit our other router configuration. Similar but not the same to what we did on router 1. Configure. Rename interfaces GE001 unit 0 to unit 13. Set interfaces GE001 VLAN tagging on unit 13 VLAN ID 13. Rename interfaces GE002 unit 0 to unit 14. Set interfaces GE002 VLAN tagging unit 14 VLAN ID 14. Right, commit quit. Once again, we're going to be looking for those peers to come up. If they don't, we want to go double check the IP addresses that are assigned. Nope, we're good. We can see that they've established right here. Our DCI updates are now complete. So we're this far, right here in the instructions. And now we're going down this way. And this is where things get fun. As I mentioned, DCA is going to have a slightly different workflow. That will clear. We know the sessions are up, so that's just waiting to come along. We're going to create a new routing policy. Oh, yeah, that's the first thing I want to do. I want to go here and create a new routing policy. This policy is required as a prerequisite for building the connectivity template. And this is where we are going to define the type of peering relationship and what gets advertised and what doesn't get advertised for our overlay. Call it core router policy. This is going to be the same between both data centers as well. Our import policy is going to be default. Our export policy, we're only concerned about the routes that are associated with our IRBs and our hosts. Create. And to the connectivity templates. We're going to have two new connectivity templates. In DCB, we're just going to edit these and add stuff to them. ext rtr underscore border 1 underscore core. I'm going to copy that so I don't have to type it twice. There we go. Same primitives, slightly different configuration this time. BGP peering and route policy. You'll note the big difference here is the routing zone we're going to associate with is tenant 1 because we are providing connectivity to the hosts that are in that tenant. It has to be tagged, of course. Give that a VLAN of 5. Everything else is the same except for the route policy. We are doing interface peering for BGP, and the route policy is going to be the one we just created. And we are going to create another. So paste border 2 core. Primitives, IP link, generic system BGP peering, route policy, IP link, routing zone tenant 1, tagged on VLAN 6. Hang on, I'm scrolling my instructions. 6, BGP peering, interface, routing policy, core. Don't need to create another one now, thank you. We're going to wait for those to generate, then we will assign them to their respective interfaces. Border 1 goes to, you guessed it, border 1, and border 2 goes to, drumroll, border 2. Let's make sure we don't miss a critical step here. We're going to go to virtual routing zones. You can see that we need, because we did this once before, but remember it was just for the underlay, for the DCI video. Now we have to make sure that we have a pool for IPs that we can assign for the overlay. So much the same way we did before, it's staged virtual routing zones, follow the red, go to generic link IPs, click this, and add the external links pool. Update that, everything goes green. I said everything goes green. Hello, staged, there it is. And we click commit. And we will go do this with a slightly different workflow in DCB, but not before we first check our protocol sessions to make sure they match the documentation that I have in front of me. So that'd be virtual protocol sessions. Since we just assigned that pool, we need to verify our IPs. We've got 8 and 9, 10 and 11. I can see from my configuration here that does match 8, 9, 10, and 11. So no special considerations there. Let's go configure this router everything's connected to once again. And add in these VLANs for our core WAN connectivity. Configure, set interfaces, GE001.5, VLAN ID 5, family, INET, address 10309/31. Set interfaces, GE002.6, VLAN ID 6, family, INET, address 103011131. Set routing options, static route 0/0. Discard. This is the route that we're going to advertise in through policy to verify that we are getting the core reachability we expect. Set policy options, policy statement, export underscore default, term, term, default, from protocol, static, and then it's the same thing, from protocol, static, default, then accept, and then we're going to do a different term, term reject, and reject. And what we're saying with that policy, show policy options, is that, and this will be our export for this BGP session that we configure here, is that we're only going to export a default route and nothing else. I could be more specific. I could do a route filter that just was a default. I know that I only have one static route configured. So in the interest of keeping all of the set commands on a single slide in my documentation, we're doing this, we're cutting a corner. And this comes back to the intent. The intent here is to get the connectivity, but for your environment, feel free to expand beyond the work that I'm doing and tune these things to your liking. Set protocols, BGP, group, core, no, export default, set protocols, BGP, group, core, neighbor 10.3.0.8, peer AS 65102, and we'll just do up. You hold down escape and hit the backspace key, pretty neat. I can just jump back and delete those. 10.3.0.10, peer AS 65103. Done. Commit and quit. Pretty straightforward. BGP summary. BGP summary. Turns out you do have to spell BGP correctly. We can see that that is already established. Let's see what we're learning and let's see what we're advertising. Show route. Advertising protocol BGP 10.3.0.8. You can see we are advertising that default in. We can show route receive protocol BGP 10.3.0.8. And you can see that we are learning the networks and the host IPs of our testing hosts. Pretty slick. Great. Oh, and all that, just in case you are wondering, all that troubleshooting stuff or that verification stuff here is in your documentation that I'm going to make available. I did mention routing instances. I think just again, in the interest of time, I don't believe that I put any of this in a routing instance because I don't recall typing in anything about show configuration routing instance. Yeah, I would certainly suggest it unless you're in a lab and that's not what you're trying to test, if you're bringing tenant connectivity out of a fabric into a router, you're probably going to want to isolate it in its own routing instance. So its route table doesn't munge around, particularly if you're multi-tenant, there's just going to be no other way to do it. In this case, I am just dumping it in the default routing instance because it'll serve my purpose. So you can see that if I misspoke earlier, it's probably because my brain is focused in on good behavior, which would be table isolation. Oh, another thing that we can check here is we can go to DC, one of these leaves. I can open that up. We can make sure that that default route's actually making it down to the leaf level. We would do that by doing just a show route table tenant, and then this would just be in the INET table. And there it is, right there. Perfect. All right, let's do the workflow for DCB and then wrap this video up. I gotta go pick my son up from school. blueprints, DCB. The route policy is the same. Policy, route policy, add, create our core-router policy. We're going to be importing defaults. We're going to be exporting the networks required for host connectivity. Create that. This is where things start to deviate. We'll go to connectivity templates, and instead of creating new templates, we are going to edit the existing templates. All right, now you see this application point represents the fabric. This represents the connectivity that we're going to be pushing out. I'm going to create a new IP link. You'll see that it starts this other part, this column. If I click on the next thing, BGP peering, before clicking on IP link, it'll put it somewhere else or something like that. It gets all goofy. So your next step, you're going to intuitively want to click this. Don't. Click on this IP link first. You'll see these things turn green. All right. Lovely. Now click on generic system, BGP peering, and route policy. And that's how we kind of build this parallel column to the DCI connectivity. A routing zone, as before, you're going to notice all of this configuration is identical, except for the fact that I got to use a different VLAN ID because I'm in DCB. And actually, technically speaking, I don't have to use a different VLAN ID, but tell me that you're going to use the same one in production for these transit networks. You're not. Don't do that. So this is another example of me trying to mimic good behavior. Routing policy that we just created and update. When I said earlier that I could see a use case for why you might do this either way, instead of having a discrete connectivity template for each of your extra, like for both DCI and this WAN core connectivity versus munging them together, it might be useful to you to have separate ones just so you know if you have to make policy edits or anything like that, where to go. It also is kind of nice to just have this be less busy and go in here and essentially use this to represent anything that is connected to that external router that link is on. You know, we don't even have to reassign links. Obviously, there's one link. So we click on IP link, we click on that so it's highlighted. We click on BGP peering and route policy, edit this. Routing zone is the tenant. This should be 16. Let me just scroll I know it is, but I do want to make sure that I am following the right workflow. 16. Down here, interface, routing policy is core. Update. Fantastic. Can't forget this step. We see some red here. Go to routing zones, assign that external links pool here. Everything should go green. Now we can commit. There we are. Commit. Done. Finally, we're going to need to build out the configuration for our external router. Go here, verify my protocol sessions for my new devices, match the documentation that I have. This is actually where things deviated in my environment. I believe my router, we got 12, 13, 14, 15. Let me update this, and actually I don't even need to make you wait for that. This is 12. Actually, no, it's not. It's 13. 13 and 15 and 12 and 14. Transit necessary. My router maybe not match yours. They're generating from a pool and I have problems. Okay, great. That's a nice teaching moment. Back to here, edit this external router. Drag it over. Let's get this set up. Configure. Set interfaces GE001.15 VLAN. ID 15. Family iNet address 10.3.0.13/31. Set interfaces GE002.16. VLAN ID 16. Family iNet address 10.3.15 of 0.15/31. Set routing options, static route 0/0 discard Set policy options, policy statement. You know what? The rest of this is actually pretty. Let me make this part at least a little bit quicker. Oh no, because I got bullets. Never mind. I'll just type it out. Set policy options, policy statement. Export underscore default term default from protocol static up term default, then accept term reject, then reject. If you don't have a from match, it matches everything, just in case you've never done that before. Set protocols BGP group core export that, and let's just save ourselves some typing. 10.3.0.12 peer, oh, neighbor. Neighbor, there we are. 10.3.0.12 peer AS 65.202 up 10.3.0.14 peer AS 65.203. Commit and quit. Show BGP summary. Hey, and look what's up. That will do it. Although this anomaly, well, those will clear because we know that those BGP sessions are up. So as always, if something's goofy, I will come back and I will show you what, but those will clear because we did just see the BGP sessions up. Thank you so much for your time. And I do look forward to seeing you in the next video, where we are going to take the connectivity we currently have and we're going to layer some of the external elements onto that are required for internet connectivity. I believe 100% of the work in the next video is going to be outside of the fabric and not involve Apstra at all. But it is neat to see the hosts that we're using for testing be able to reach the internet. And I want to give you some sort of idea of how you can accomplish that in your own lab if you're interested in doing so. Have a great rest of your day. See you in the next video. Take care.